Actually, in this chapter, what we are doing actually, motion, motion means the motion of the earth. Earth revolves around the sun, and you can see the vehicles on road are moving, and this fan is moving. My hand, the motion of my hand, okay, the motion of my eyes. These all are motions. And here, what we are doing, we are just describing the motion into the words, and that words is, and when you write some word, like in English you write words, and from the words it becomes sentence, and that sentence form into a language. So this is the language that we are dealing, and that is known as physics. Okay. Okay, so by the way, rest and motion. Rest, I have told you. Motion, I have told you. Frame of reference, this frame of reference I have told you, and I have said, whenever your frame of reference will change, the condition of rest or motion will change. So Divyangi, I will ask you one or two questions. Right now, I am here now, like this. So right now, I at rest or in motion?
Address.
Hmm, actually, this answer is not correct. Actually, you can suppose I am here now, and someone is on the moon. Okay, and when someone is on the moon, or you can say someone is on the train, and here, like here, train is going, like from here, some train is passing, and the person in the train is watching me. The person in the train is watching me. For that person, I will be at rest or I will be in motion. Means whenever we go uh, to the plane, like you can take the example of aeroplane, you can take the example of train. The train passes, like the trees and all that. What appears to you? The trees that are passing in motion or in rest?
Motion.
Motion, na? So why? But in actual, when you are on the ground, when you are on the ground, that trees and all that will be in motion, will be at rest. Okay. So this is happening because you are just changing the frame of reference. Means first, if your observer is in the train and he is watching the person in the train, so he will see that the person in the train will be at rest, and he when he will see a person which is outside of the train, and okay, then that person will become uh, in the motion for that person in train. Are you getting?
Yes, sir.
I think I don't want to make it complicated. Just so we have discussed one dimension motion, two dimension motion, and three dimension motion. And after that, we have discussed distance and displacement. Distance and displacement. Okay. And displacement. So Divyangi, what is displacement?
Sir, I think this is my first class after the demo.
Huh? So in demo, I have told you this. I have not told you the distance.
Sir, you were teaching vectors.
Oh, you are sorry. I think that day. I think you have not joined that day. I have not teach this to you. Motion in a straight line.
No, sir.
And I am teaching again and again, again and again. And sorry for that. I think you are. This is our second class after demo.
Sir, first class.
Oh, this is our first class after demo. So I think that student was someone else. Okay, no problem. So just I think there is she is another student named Kripa. At that day, I was teaching this thing. Okay, no problem. Just leave that. Okay, sorry, Divyangi. So that day I was teaching you the vector, and now I have remembered. You told me that work power energy is going on in your school. Is it or not?
Yes, sir, and it's over.
And it's over now. So just wait a minute. So I am starting that day. I have told you about the vectors. Okay, that day I have told you about the vectors. Now, from this class, I am starting the chapter number 3 of NCRT. That is motion in a straight line. Okay. Should I start from motion in a straight line? Because this is the starting of the physics. Okay. Divyangi,
Okay, sir.
means uh, are you fine with it?
So can we do from motion in a plane?
Actually, for we can do, but there are some concepts here, na, that will be required in the motion in a plane. So that is why I am starting from the motion in a straight line.
Okay,
And
sir.
this is, are you actually think, listen, actually we are studying the mechanics. Okay, we are studying the mechanics, and in mechanics, things are linked to another things. Things are linked to another things. I can start from the work power energy also if you want, but according to me, if we will start from the motion in a straight line, I think all the concept all the concepts of your will be crystal clear. I think. Okay, because
Yes, sir.
yeah, and this chapter is not lengthy chapter. This is very basic chapter, and please remember one thing. This is the same chapter that you have studied in your ninth class. In the ninth class, I think if you have remembered, then this is the same chapter. Okay, so I'll always I start from the beginning. Okay, so now I am starting the chapter number 3 of NCERT, and soon we will go to the chapter number 4, that is motion in a plane. Okay,
Yes, sir.
okay, so chapter number 3. So why you are absent from so many classes? Motion in straight line. That day I think I have taught to some other student. So motion in a straight line. Straight line means this is a straight line, okay, and you are moving on this straight line like this. This is you, and you are moving in a straight line. So in this chapter, we will describe the motion. Yeah. And this chapter start from the concept of rest and motion. Okay. Rest and motion. So uh, rest. Hmm. This thing I will explain you with the help of one example. Because in physics, if you know the derivation, if you only know the definition, means what is distance, what is rest, and what is displacement, and all that, means uh, these things are not sufficient. You have to understand the physics. Okay, you have to understand the physics. For that, suppose this is a compartment of a train. This is a compartment of a train, and suppose here is one person. This is A. This person is A in the train. Okay, and this train is moving like this. This compartment of train is in motion,
Yes, sir.
and this compartment of train is going in this direction. And please remember that we are discussing the what is rest and what is motion. In 5 minutes you will get it clearly. And here is another person B. This person is here, and this person also sitting its on his seat, and this person is also sitting here, and this person is also sitting. Now here is another person C on the ground. Suppose this is the ground, and here is another person on the ground. This is ground. Suppose this person is C. Now when A will see this person B, when A will see this person B, so according to A, this person will be in rest or in motion. According
Rest.
to, very good, very good. So you can say right here, with respect to A, with respect to A, B is at rest. But when this person C, when this person C is watching this person B, so what can you say with respect to this person C? This person B is in rest or is in motion? Suppose you are outside the train and some of your friend is in the train, and train is in motion, and you are watching your friend. So according to you, just imagine, according to you, that your friend will be in motion or in rest.
Motion.
Very good. So according to this person C, this person B is in motion. Okay. So you can write with respect to C, V is at V is in motion. V is in motion. So see, this person B is in motion also. This person B is in rest also. So why this thing is happening? Because you are changing your observer. Okay, you are changing your observer. Here your observer A, this is the observer, na? This is your observer. This is your observer in the train, and this is your observer outside the train on the ground. So if you will change your observer, then the condition of rest or the motion can change accordingly. So you cannot say a thing is completely in rest or a thing completely in motion. Okay. So now talking about the definition. Talking about the definition. Hmm, what is rest? So rest is no change in position with respect to time this is incomplete definition and we have to add something else and with respect to frame of reference frame of reference frame of reference is a thing where the observer is present where the observer is present. Okay.
Yes, sir.
Yeah. So from now if someone is asking you what is rest, so you will not say that if the position of the person is not changing with time means it is in rest. No, you will say there will be no change in position with respect to time and with respect to frame of reference. And this frame of reference is a thing where the observer is present. So just I am writing what is frame of reference. Frame of reference is designed to observe the motion, to observe the motion. And please have patience, all the things will be clear at the end of the lecture. So frame of reference frame. Now what is frame of reference? Frame of reference is a place of observation. Place of observation means here in this case the frame of reference is ground. Okay, here the your frame of reference was ground, but here the observer was on the train. So the frame of reference you can say is the train. Okay, so frame of reference is the place of observation and it consists of coordinate system to measure position, to measure position and a clock to measure time. So Divyangi, just tell me one thing. If you want to find position of any object, if you want to find the position of any object, so what will you do? There is a requirement of coordinate axis now. Means like this. This is the coordinate axis. So suppose this is x-axis, means this is positive x-axis. But do you have any idea about the coordinate axis now?
Yes, sir.
Okay, very good. This is positive x-axis and one thing more, this is origin. This point is origin, this is the positive x-axis and you are going in this direction means you are going towards the negative x-axis. And this is positive y-axis This is negative y-axis, and we define the motion in three axes. Okay, there is only requirement of three axes: x-axis, y-axis, and z-axis. So this is negative z-axis. This is positive z-axis. So why there is a requirement of these axes? Because for the position, if you want to find the position of a body, then only you can analyze the motion. No? Suppose initially the body is here at this point here. If the body is moving along the x-axis, so if you have these coordinate system, means this coordinate system, then with the help of this coordinate system, you can measure the position easily. Okay, and other thing is a clock to measure the time. Okay, and you have the coordinate system, not you. uh, there will be an observer here. Suppose at this O, here is an observer, and this observer have a clock also. Okay, this observer have a clock also. So this observer, what this observer will do, this observer can measure now the position of the body by using the coordinate axis, and there is a requirement of time also. Mean at what time, what is the position of the body. So with the help of the clock, he can measure the time. And if you know the position of a body and the time where is the body, then you can describe the motion of the body. So this is the frame of reference. So here, what is the frame of reference? Just you can take this as the example. So here, for observer 1, frame of reference is this train, and this ground is the frame of reference. So I think there is no need to write. Now I think you have understood what is the frame of reference. Clear?
Yes,
Till here?
yes, sir.
Suppose someone is observing the motion from the moon. Someone, suppose I am sitting in my room right now, and someone there at the moon is observing me. So can you tell me what here? What is the frame of reference?
Moon.
Very good, very good. This thing should be clear. Many students have doubt in the frame of reference. Means frame of reference is a point. Frame of reference is a place, you can say, where first your observer will be present, and with that observer there are coordinate axes to measure the position and a clock to measure the time. Simple. So there is one note point: rest and motion are relative, not absolute. So that's not absolute means nobody can be in the rest or can be in motion without the observer. If there will be an observer, then only we can say the body is in rest or is in motion. You can write, there is no rest and motion without observer. So tell me one thing, Kripa. Suppose you are here right now. Suppose right now you are here. So you can move either on the x-axis or on the y-axis or on the z-axis. Means if you have three axes, then you can either move on x-axis or on y-axis or on z-axis. Okay,
Yes, sir.
if you are moving in one direction, or if you are moving in a straight line, then you have only six choices. Either you will go towards plus z-axis, either you will go towards minus z-axis. Okay, either you will go towards positive y-axis. So
Yes, sir.
this is the thing. And now I will describe what are one-dimensional motion, what are two-dimensional motion, and what are three-dimensional motion. Motion in one dimension. So motion in one dimension. First, I will write the definition, then I will explain what is. So motion in one dimension. During motion, during motion, if only one of the coordinate changes. One of the coordinate means from x, y, and z. You have three coordinate axes, so you have three coordinate. One coordinate x, y, and z. Okay. So if one coordinate is changing during your motion, then you can say that motion is one dimensional motion. Changes from x, y, and z. This is x, y, and z. So from the example, this will be clear. Suppose you are moving in a straight line. Here, come here. Now see this. Suppose you are moving in this direction, in this direction, in this direction, in this direction, and now. So your only x coordinate will change. Your only x coordinate will change. Suppose you are moving on this z axis like this, like this, like this, like this, like this. Only your x coordinate will change. Only your z coordinate this time will change. Suppose you are moving only along the y axis. So your y coordinate will change. So you can take the example whenever you are traveling in a straight line, whenever your motion is a straight line motion, then you can say motion in one dimension. Motion along x-axis, you can say. Or you can say motion along y-axis, motion along z-axis is an example of motion in one dimension. Motion along y-axis is also the example of motion along z-axis. When you will move along the x-axis, your x coordinate will change only. Y and z coordinate will remain same.
Yes, sir.
So motion in one dimension. Now motion in two dimension. For dimension, I will write D. So motion in 2D, two dimension. So if you will write the definition, then according to the definition means you can say during motion, if two coordinate changes from x, y, and z, then motion is two dimensional motion. That you are talking about, that in the beginning you have told me that please teach the motion in a plane, and motion in a plane is a two-dimensional motion. Okay, motion in a plane is an example of two-dimensional motion. So during motion, I am writing the definition. During motion, if two coordinates change from x, y, and z, no problem, you can write this also. So if you will take the example, And you can take the example of a insect, the motion of the insect on the floor, the motion of the insect on the floor. So you can write insect crawling on floor. But remember, this insect has not, insect is not having wings. Okay, this insect cannot fly. So that is why I have written here insect crawling on the floor is an example of two-dimension motion. How this is an example of two-dimension motion? So two-dimension motion, always remember that is a plane motion. Okay, two-dimension motion is a plane motion, also known as planar motion. So suppose you have this plane, na? You have this plane. You can see here. This is plane, suppose. And suppose here is some insect, and this insect is moving like this, like this, like this, like this, like this. Okay, not moving in a straight line, but moving in a plane. So that motion, in that motion, your two coordinates will change. In that motion, your two coordinates will change, and you can say this motion is a two-dimensional motion. So you can take the example of insect crawling on the floor. Your floor is a plane. Suppose if some insect uh, is in motion or is crawling on your screen, so that motion will be one dimension or two dimension. Divangi,
2 dimension.
very good. Two dimension motion. Can you name other uh, example? Just try. Have you heard the name projectile motion?
Yes, sir.
Okay, that I will discuss if we will have a class. Then I will discuss the projectile motion in a plane. That is also the example of two-dimensional motion. So just right now, this is okay. Insect crawling on the floor. And suppose this insect have the wings. This insect have the wings. Now this is apart from motion on the floor. This insect start flying also. So what type of motion will it become? Now this time three coordinates will change because when earlier this insect is crawling on the floor, means performing the two-dimension motion, but this time this insect is flying also, means there is an involvement of one more axis. Okay, there is involvement of one more axis, so that motion is three-dimensional motion. Just motion in three dimension, motion in three dimension. So here we will write during motion if three coordinates change, if if all of the three x, y, and z coordinates are changing, then you can say the motion is a motion in 3D. And for example, you can take the motion of aeroplane in the sky, motion of insect having wings, okay, motion of the words, okay. So can write here motion of aeroplane, sky, motion of birds. Divyangi, can you give me one more example? Just you can try it.
Sir, that insect with wings.
Yeah. All right. You are right. Motion of a kite is also motion in three
Yes,
dimensions.
sir.
So after this, we will discuss distance and displacement. And I know that you already know what is distance and displacement, but we will discuss that. So distance. Distance is simply, you can say, actual path covered by the body during the motion. Actual path covered by body. Simple.
Yes, sir.
Suppose you are moving like this and like this and like this and like this. Initially you are here and you are moving like this. Then you came to this point B, then you came to point C, then came to point D, and finally you are at E. So I will represent this distance with a small d. So this distance will be the path length, the actual path you have covered. Like here you will write, you will measure this distance AB plus BC plus CD plus D. So you will write this AB plus BC plus CD plus DE. Okay. So suppose if a body is moving in a circle, suppose this is a circle, na? Circle of radius R. Okay, and a body has started the motion from this point A, and finally this body reached to the point B, and we want to find the distance in moving from A to B. In moving from A to B. So what is the distance? Distance is the actual path covered by the body. What is the actual path covered by the body? This path, this semicircular path means this circular path. This
Yes,
time is
sir.
the, yeah. So can you tell me what is the distance?
Pi r.
A 2 pi r divided by 2. Okay. And suppose if a body is in motion, so now if a body is in motion, can distance decreases? If a body is in motion,
No, sir.
very good. So distance of a moving body always increases. And now we will draw graph. If someone is giving you graph like this is the graph, and someone is giving you the graph like this, and the graph is like this, and again, then this. And this is the graph between the distance and the time. So can you tell me this graph is valid or not valid? Is this graph okay or not okay? Hello, Divyanji.
Sir,
So
I was disconnected.
no problem. Last point was I have written distance of a moving body always increases. Okay, so you have to remember this point, and you have to check this graph whether this graph is correct or incorrect. So see here, suppose you are here, uh, at this point. At time t1, your distance is this, suppose d1. At time t2, your distance is d2, means this time your distance increases, and this is d2. Now suppose at time t3, you are here. So with respect to the time, here in this graph, the distance is increasing or decreasing? See here, suppose this is the time t2, this is the time t3. So as the time passes, time will always increase. Okay, time cannot decrease here. Okay, in the Newtonian mechanics, the time will always increase. So here the time is increases and the body is in motion. But here you will see that the distance is decreasing from here to here, from t1 to t2 the distance is increasing, but from t2 to t3 the distance is decreasing. So I have told you distance of a moving body always increases, but here the distance is decreasing, so this graph is incorrect.
Yes, sir.
So in the examination the examiner will can give you the 2 or 3 graphs, okay, and he or she can ask you whether these graphs are correct or not. So take another graph. Suppose your body is moving like this, moving like this, and this is the distance time graph. This axis is distance and this axis is time. So can you tell me this here the distance is constant? Can you tell me this graph is correct or incorrect?
Correct.
Very good. So what do you say about this? Distance is not changing means the body, this is like this. Body starts the motion from A, and suppose here is some restaurant or something, and here the body is at rest. And again the body after certain period of time starts motion. Finally the body is at C. Suppose this is O, this is A, this is B, and this is C. Initially the body is at O, this is at O, the body is at O, and then at A. From A to B, the distance is not changing. So I have to just change it. From A to B, the distance is not changing, means the body is at rest. But from B to C, again, A and B are the same points. You can see. A to B, the distance is not changing. So there is no requirement of this. It means you have this graph is correct. So now we will discuss displacement. Displacement. So displacement is simply the shortest path between the initial and the final position. Shortest path between initial and final position of body. Initial and final position means suppose initially your body is here and you are moving like this. Moving like this. And finally you are here. Okay, finally you are here. So A, B, what will be the displacement? Displacement is the shortest distance. Shortest distance means if someone is saying the shortest distance, always include straight line distance. Okay, so shortest distance means this distance. Okay, AB. So AB will be your displacement. So suppose initially a body is at A and the body is moving in this direction like this, and finally the body is reached at B and now the body is moving in this direction, and finally the body is again at A. Body is again at A. So what will be the displacement here? 0?
0.
Yeah. If your initial position and final position will same, then displacement is 0. So displacement here. So displacement I will represent with S. So displacement S here is equal to 0. And displacement can also decrease with time. Displacement can also decrease with time. Suppose you are moving like this. You are moving on the straight line. Okay. Initially you are at this A. Finally you are at B. What happened? You are moving in this direction initially, like this, like this. Now you have reached at point B. So when you are moving from A to B, your displacement was suppose D. Okay, or you can take this distance as 10 meters. Suppose you have moved 10 meter. So this time your displacement, what is your displacement? 10 meter. But now what happens? Now you are returning from this point, from V to, suppose finally you are at C and you have moved a distance of 4 meters, suppose. So what is your final position? Your final position is C. This is your initial position. This is your final position. Okay. So now your displacement will become 10 minus 4, 6 meter. So with respect to the time, here you can see that displacement can also decrease. Okay. And there is one more simple point that we have discussed, that if the initial and the final position are same, then displacement is 0. So I am not writing this point. In case of displacement, as displacement is a vector quantity, Divyangi, do you have any idea about the scalars and the vector? Means vector I have told you. I want to
Yes,
ask
sir.
you. Okay. In the demo class, I have told you the vectors. So I think now you should know the vector. So displacement is a vector quantity. Displacement is a vector. And in this chapter, we will discuss the motion on a straight line. Motion on a straight line. So there will be no requirement of vector, but there will be the requirement of vector when there will be a motion in a plane. When we will discuss motion in a plane first, then we will discuss vector again, and then we will move to the projectile motion and all that. So in case of motion in a straight line, we can just deal it without the vector. So You can write one more point. Displacement can be positive, negative, or zero. Zero you have seen. Positive displacement also you have seen. This 10 meter is a positive displacement. Zero is the displacement here, is the displacement zero. But what is negative displacement? Negative, for the negative displacement, you have to choose the direction. You have to choose the direction. Suppose your body is like this, and suppose this is the origin, and if your body is moving towards positive x-axis, suppose your body is at A, then you will take this OA as positive displacement. This is the sign convention that I am telling you. And if your body is moving towards negative x-axis, okay, like this, if your body is moving, suppose finally your body is at C, then OC displacement you will take as negative. Okay, displacement. So, just I am giving one question. Suppose a body is moving like this. Body is moving from A to B to C. Okay. So you are at here B, and if you have moved 5 meter in this direction, okay, 5 meter in this direction means you will take this 5 meter displacement as positive 5 meter, and if you have moved 5 meter in this direction, then you will take this 5 meter as minus 5 meter. So okay, write it in the form of point. And this is a vector quantity, and for the distance, please write the SI unit also. For the distance, the SI unit is meter. You already know this. And same SI unit is for the displacement. What is displacement? Displacement or distance are simply the length, and the SI unit of length is meter. So talking about the SI unit, so you will write meter. And there is one note point. Distance is always greater than or equal to displacement. Distance is always greater than or equal to displacement. And tell me the condition when this, suppose this is a distance and this is displacement S. Tell me the condition when D is equal to S. Divyangi, I have told you the condition in the beginning, that in which condition the displacement is equal to the distance. Okay. Suppose you when you are moving in a straight line, when you are moving in a straight line in the same direction, then your distance and displacement are equal. Motion in straight line in same direction. You can think this with the help of example. Suppose you are moving in a straight line like this from A to B. So your distance and displacement this time will be same. So your displacement is again AB and distance D is again AB. D is again AB. Okay. Divyangi, is it fine?
Yes, sir.
These are very simple. This lecture is very basic lecture. So I am just taking one question. Okay. This question is from the 9th class actually. In 9th class, I think you have done this question already, but I am discussing it. Suppose a body initially at A and finally at B, and suppose R is the radius of this circle, and a body is moving on this circle. Okay, a body is moving on this circle, and initially at A, finally at B. So you have to find the distance and displacement. Distance and when the body moves from when body moves from number one A to B. Second, this is another point here, A to C, and third point, uh, after one complete revolution. Very simple question. This is the last question of the class. So see this. So the first answer you can write this. When you are moving from A to B, the distance will be this arc length AB. So Divyangi, tell me what is this arc length AB?
Pi r by 2.
You are right. Means whole path length will be 2 pi r and divided by 4 means quarter of the circle is completed in going from A to B. So this will become pi r by 2. And what is the displacement? This is the distance. Just tell me the displacement, and I am just leaving this class now. What is the displacement? See, displacement is the
Root r square plus r square.
yeah, very good. Displacement is equal to root r square plus r square. You have just applied the Pythagoras theorem here. R square plus r square. This will become root of 2r square. That is root 2r. Okay. Second part. What is distance? Pi r by what is distance? Pi r, na?
Yes, sir.
From A to C. So you will write this distance is 2 pi r divided by 2. So this will become pi r, and for the displacement r plus r. Okay, this is
2r.
again r, 2r. R plus r is equal to 2r. And for the third part, distance is 2 pi r and displacement is 0. See here, after
Yes.
one complete revolution, the body will be at A again. So distance will be the distance covered in for the whole circle, that is 2 pi r. And just after that, in the if we will have the next class, then I will discuss one thing. And this thing is from the 11th class. Now these are the things that I was discussing was from the 9th class. This is the first lecture of straight line motion. So suppose the body is now here at this position P, and this body is making an angle 60 degree. So we have to just calculate the fourth part of this question, uh, A to P, and we have to calculate the distance as well as displacement when the body has moved from A to P. This question and this thing, uh, if we will have next class, then definitely I will discuss this. Okay, so you can note. Would you like to note it down, or would you take the screenshot?
Sir, screenshot.
Take the screenshot. Taken?
Yes, sir.
Okay. No.
Yes, sir.
Done.
Yes, sir.
Very good.
Done.
Very good. You can now take this screenshot.
Yes, sir.
Done. Done. Okay.
Done.
Done. Take this.
Yes, sir. Done, sir.
Done. Now take this.
Yes, sir.
Now take this whole question. And this part, this fourth part, na, if we will have next class, we will discuss in the next class. Okay. Till then. So these are the concepts that I have discussed in today's class are from basically from the 9th class. From the 9th class. Okay. Is there any doubt, Divyangi?
Sir, can you show that Cartesian plane?
Okay. This na.
Yes, sir.
So just a minute. Again showing it. This Cartesian plane na.
Yes, sir.
Actually, this is not a plane. Here are 3 planes: XY plane, YZ plane, and ZN plane. These are Cartesian coordinate axis. Okay. So this is not a plane. There will be 3 plane here. We will discuss this all the things now. Then we'll discuss the motion in a plane and all things I will discuss. Here is one XY plane. Here will be one YZ plane. There will be one ZX plane. So Divyangi, so this frame of reference is clear now.
Yes, sir. So when you
So
were moving your cursor along the minus z axis, so it was seeming that x and y coordinate are also changing.
no, now this time I am moving my cursor along the negative x-axis, na?
The z axis.
Along the z-axis I am moving. So you are saying that it is looking like that my x and y coordinate are changing. Yes, you are right. If I will do this, definitely change. But this thing you are watching on 2D plane. You are watching this thing on 2D plane, but in actual what is happening, actually I don't want to go in deep this time because we are at very starting. So just see this. The thing is happening. You have this xy plane and you have this z axis. Z axis is perpendicular to xy plane. Okay, like this. And now what is happening there, na? you are moving on this axis. You are moving on this axis. That z axis, when you are moving now, you are moving on this axis. So that is why your x coordinate and y coordinate will remain same. Okay, you will do this when you will get this when you will try to think